Okay, so page 18, we are starting to do transformation. Okay, so before this chapter, we talk about all the different kinds of function, inverse function, right? Composite function, and how to add, subtract, multiply, divide between functions. Now in this chapter, we are gonna just focus on one function at a time. Okay, so there are 6 basic functions. So you can think of it like 6 different kinds of cars. Okay, if you guys have seen Transformers, right? Different cars can transform into different shape. Some, well, it doesn't have to be cars, right? You get electronics, radio robots, right? You have the truck, right? The truck is one kind of car, right? So you have 6 different kinds here. And then we need to recognize these 6. After you recognize these 6 kind of cars, then you will learn how to transform them. Okay, transform means make them into different shape. Okay, so there are 3 types of transformation ways. So first one is called reflection. Okay, so that's part B. And then we can also stretch it or shrink it. Okay, make it bigger or smaller. Same with the transformers, right? They can turn into bigger or smaller, right? And then we have the last one, translation. Translation has to do with moving. Okay, moving to the left, moving to the right, just like the airplane, right? It can fly up, fly down. Okay, so 3 different ways to transform. So eventually, right? So if you look at the basic means they look very simple, right? Like parabola, you look at this, the first one, just y equal x squared, right? So we need to know what it looks like originally, right? Without any transformation. And then later on, our goal today, well, not today, I think after tomorrow, next week, if you look at something like, let me show you an example. So you should be able to do, how come I don't have it? Okay. Yeah, so for example, like this one, right? You look at number 11, right? So you look at this, you see, oh, this one has a square, right? Has a little square. So it belongs to the square family, right? The basic graph of the square. But then it has the extra 2, right? The extra 1, the extra 3. What does that do? So we're gonna learn what those things will do to the graph to make it look different. Okay, so that's what this chapter is about, transformation of the functions. And this chapter is very, very important because these 6 is just the 6 most common ones. But you can apply the same idea to any function you are going to encounter in the future. Okay, like later on we have a chapter on trigonometry, sine, cosine, tangent. You can also apply transformation, the 3 transformation to that as well, right? Later on we have a log, that's also a graph. You can also apply transformation to that. So even if you move on to higher level, when you are learning in university, right, you see other functions, all these ideas still applies. Okay, so this is a very important skill, how to tell transformation. Okay, any questions? So we'll start with the basic, okay? Just get familiar with the basic functions. So when you get a question, you need to match, okay? Think about, oh, does this belong to number 1? Or does it belong to number 4, right? Which family of the function belongs? Okay, so let's start with the most common one, right? The parabola. So what you need to do is to remember the points that you need to get a basic, okay? The first one is the quadratic. Okay, let's put that down, put the name down. Quadratic function. The basic points for the x is -2, -1, 0, 1, 2. Okay, so I'll let you complete the table, okay, and also do the graph. Okay, when you finish the first one, you can raise your hand. So input each x value into the x. I'll do the first one. For example, first one will be -2 squared, right? So before, so you have a point and -2, 4. Okay, so finish the table and graph and raise your hand. Okay, next one should be 1, right? -1 square will be 1. 0 times 0 will be 0. 1, 4. Okay, are you guys all done, Jocelyn and Marcus? Have you finished the graph?
Yeah.
Okay. Raise your hand if you're done. Okay, so you get a problem, okay? So these 5 points you need to memorize because we need it to transform and get the new points, okay? So all these table, right, you need to memorize. But the easiest way, right, because I don't like memorizing things, so usually I just remember the x. Okay, the y, I will just get it on the spot, right? Because they will give you the function, right? You just plug it in, -2, -1, 0, 1, 2, right? You know it's square, right? And then you know right away 4, 1, 0, 1, 4, okay? Okay, Justin, are you done the graph yet? Okay, so the second one, you have a cubic, right? X to the cube. So instead of square, we have cube. So we call that a cubic function. Okay, very straightforward, cubic function. The x value, once again, is the same, -2, -1, 0, 1, 2. Okay, so easy to remember, right? So also memorize the x for this one. Okay, so please complete the table one more time and raise your hand, okay? Finish the graph. This time you need to cube, okay? -2 to the cube. I'll do the first one, -2 to the cube. So -2 times -2 times -2 will still be negative. So the first point is at -8. -2, -8. Okay, so it'll be down here. Okay, please raise your hand if you finish the graph as well. Okay, -1 to the cube is -1, right? 0, 1, 8. Okay, -1 should be here. 0, 0. Okay, but it's not opening down, right? It looks like a parabola, but it's not. After that, right, the positive side continue to go up. 2 will be 8. Okay, so I think most of you have seen this before. And not a straight line, okay? It's a curved line, so it goes like that. Okay, please raise your hand if you are done. And then we'll move on to the third basic graph. Okay, Marcus, finished?
Oh yeah.
Yeah. Yeah, please raise your hand, okay? All right, next one, Angela, what is this one called?
The absolute value.
Yes, very good. Okay, absolute value. We saw this in the function, right, as well. Absolute value function. But we didn't do much in the last chapter, right? We just did in the composite function, we put one function into the other one, but we didn't mention what it does, right? So Philip, how do we use this function? Let's say if the input is still the same, -2, -1, 0, 1, 2, what would it do?
So I'm not good at explaining, but basically, like, it's absolute is only counting for the distance of the number from 0 on the number line. So you just remove the negative.
Okay, very good. Okay, so the key word is, you mentioned it's the distance. So let's say we have -2, right? On the number line, here's 0. If I have a point at -2, the distance from -2 to 0, when we talk about distance, we don't care about directions, okay? So it's just trying to find how far. So you will say the distance will be 2. Okay, so that answer will be your y value. Okay, so what's happening here is if you put -2 into the x, it's telling you, is basically asking you to find what's the distance from -2 to 0. Okay, so then the answer is 2, because it's 2 steps away from 0. Okay, so that it means distance. Okay, this is distance. So that's why it's always positive, right? So same thing, please complete this table and make a graph. After you've done that, you can raise your hand. Okay, Susan, so what's the next y value?
1,
Yeah, very good.
0,
And yeah, okay, go on, next one.
1 and 2.
1 and 2, okay? So if it's 0, then it's right at the origin, right? So the distance is 0. So it's the same as asking how far are you away from home? If you're at home, right? Then you're saying 0, right? I'm just at home. Okay, if you finish the graph, please raise your hand. So -2 will be here. -1, 1. 0, 0. 1, 1, 2, 2. Okay, so would it be a curved line? Does it look like a curved line? It should be a straight line, okay? So you have a straight line going to the right side like that. Another straight line. V shape. Okay, Angela, Jenny, and Justin, Marcus, are you done?
Oh yeah.
Okay, please raise your hand if you finished. So far, the three graphs that we have, the table is very similar, right? They all have -2, -1, 0, 1, 2. Okay, very easy to remember. But the next one, it doesn't, okay? Because you get square root, you cannot have negative inside square root. Okay, so we are not going to use the same x values. So let's put a star on this one. That's a messed up star. Okay, so right here. Okay, so the x value for square root. Well, first of all, the name. Okay, this is called radical function. Jenny, are you done with the third one? Jenny? Jenny, are you there? Jenny, are you awake? Okay, if you guys like need to leave for a minute, like maybe go to washroom or get a drink, right? You gotta let me know. Otherwise, I'll be calling, right? Jenny, are you there? Okay.
Yep, I'm good.
Yeah. Okay. Did you go away?
No, I was here. Sorry, I forgot to raise my hand.
Okay. Okay. Yeah. Okay. So the fourth one, radical function. So instead of using -2, -1, 0, 1, 2, the smallest number we can use will be 0, right? Because we cannot use negative. So we are going to use negative, not negative, right? We cannot use negative, so we'll put 0. And we'll choose the numbers that are easy to square root, okay? Because if you choose something like 5, it's difficult to square root of 5, right? You'll get decimal. So next number we can use is like 1. The perfect squares, okay? 4, 9, okay? After that might be too big to fit in to the graph. Okay, so we use these 4. So just for radicals, we use these ones as our basic points. Okay, so I'll let you finish the graph as well, and you can raise your hand. So just remember, only for the fourth one, you use a different x values, okay? Everything else, you use -2, -1, 0, 1, 2, okay? So the table is pretty easy to remember. Okay, so let's get the points. Okay, Eric, can you tell me the table? What goes into the y's?
The first one is 0,
And then,
1,
yeah,
2,
yeah,
3.
yes. Okay, so square root of 9 will be 3. 0, 0 right there. 1, 1, 4, 2, right? 1, 2, 3, 4, 2. 9, you can barely fit it a little bit outside, right? Just to know the way it bends. And this is the upper half of the inverse, right? Remember we just did the inverse. It's the upper half, right? This is open to the right side, right? We're missing the lower half. Okay, the lower half, the upper half, this one is the upper half because this one gives you a positive square root. If they give you something like negative square root x, they will give you the lower half. Okay, so you can see that the negative does something to it. Okay, so later we'll be talking about that. Okay, right now just keep it as positive. So remember this, for the basic, we use the positive side. Okay, please raise your hand if you are done this one. Okay, still have 2 more to go. Okay, Eric, are you done with the graph? Okay, all right, next one. Okay, so this one is a new one. Okay, maybe for some of you. You have x in the denominator. This one is called the rational, right? Because rational means a fraction, something like a fraction. So call this a rational function. Okay, so write this down, and then we are going to use the same points. Okay, easier to remember. So let's go through the points together. This one is different from all the other ones. So Chris, what's the first y value?
Negative 0.5.
Very good. Okay, I'll put negative half. Okay, and then Evan, what's the next one?
Just -1.
Yep, -1. So 1 over -1 is just -1. All right, and then the next one, Sophie?
Doesn't exist.
Doesn't exist. Very good. Okay, so that's where the trouble comes from. 1 over 0, but you cannot have 0 in denominator. So you can write it as DNE, does not exist. Or you can write it like this symbol, 0 with a slash. That means it's empty. Okay, there's no value there. So that means on the graph, you cannot put anything there, right? When x equal to 0, it should be an empty space. Okay, next one will be similar. Okay, so 1 over 1, 1 over 2. Okay, so all the x value will go into the denominator. So let's plot the points first. -2, -half. Okay, -2, -half will be here, right? -1, -1, -1, -1 will be here. And 0, when x equal to 0, you cannot put any points. So that means along the x equal to 0, it should be completely empty. So to show that, we draw a dotted line. So every point that I'm showing right now, right, the dotted line, every dot here on the y-axis means they're empty, okay? It's like an invisible wall. You cannot put any points there. Maybe I should use a different color, okay? So the red is the graph, but then I'll use the green. Okay, this line, it shows it's an empty space. This line, we have a name, it's called the asymptote. Okay, later we have a chapter about asymptotes, okay? So we will learn more about it. Right now, just remember for this one, because undefined, right, does not exist. So we need to put a point, that dotted line there. Okay, and then the other side, 1, 1, 2, half. Okay, So the way to graph this, it will be bending like this. Okay, so the closer to 0, the closer the x to the 0, it will go higher, right, from the right side. Now, if you think about the other side, right, moving to the right side, let's say if x continue, right, x equal to 3, it'll be 1/3. It will get even smaller, right? X equal to 4 will be 1/4, right? The denominator gets bigger and bigger, so value gets smaller, so it will go down. So there is another asymptote line because it can never become 0 because of the 1 in the numerator. There's always a 1 at the top, right? So you can never get 0. You get bended graph. Okay. So same with the other side. Okay, it will look like this. So just right now, you just remember this rational function, right? If it's a basic, it should look like this way. Okay. Just add this to your list. Right, when you finish this one, can you raise your hand? But you just remember this section, okay? The basic points. So we have two asymptotes, okay? This is also asymptote. Okay, Eric and Marcus, are you done?
Yeah.
Okay.
I'm just copying down the notes and like the asymptote part, and then I'll be done.
Okay. So far, does anyone have questions? Okay, we covered 5, okay? So later we'll be transforming all these ones. Okay, Marcus, ready to move on to the next one, number 6?
Yeah.
Yeah, okay. So the last one here, the basic is called the exponential function. Okay, I guess you can see why it's called that name, right? You have x in the exponent. So it's called exponential. Okay. The point, right, to make it easier, we're still gonna use the same, okay? So you can see all the points are the same except the radical, right? So just remember, radical, you have special points. So please plug it in. And do you remember what happens when the exponent is negative? Okay, try to complete this table by yourself. Let's do the first one. Okay, let me get your answer for the first point. Jenny, how do we get the first y value?
We plug -2 into the exponent, and then it should be, I don't remember how to do negative exponents, sorry.
Okay, it's okay. Yeah, let me ask someone else. Nick, what does it do?
So you put it in a fraction, basically. So you put it's 1/2 to the power something. So
Yeah.
you take the reciprocal and then turn the exponent positive.
Very good. Okay, so if you see a 2 to the -2, the negative is just telling you to put it to the other side. Okay, so if it's -2, it will become 2 when you put it to the other side. So if you see 2 to the -7, then you flip it over, it will be 2 to the 7 on the other side, okay, at the denominator. So at the end, you end up with 1/4, okay? So our first point is at -2, 1/4. -2, 1/4, right? Just roughly there. A little red dot. Okay, so same thing, please raise your hand once you finish everything here. So Jenny, can you try again? What's the next point then?
Is it 1/2 to the power of 1, which is just
Yeah,
1/2?
Yeah, very good. Okay. So negative is like an airplane ticket, right? Just flies it to the other side. Okay, Daniel, what's the next one?
It's 1.
Very good. 2 to 0 should be 1. Okay, do not put 0. Okay, Jocelyn, next one.
Two.
Yeah, 2 to the 1 is just 2. And then 2 to the 2 will be 4. Okay, so please finish the graph and raise your hand. -1 is half, so a little bit higher, right? Half is bigger than 1/4. 0, 1, 1, 2, right? 2, 4. Shouldn't take that long, okay? If you finish, please raise your hand. And connect, okay? Now we want to see what happens if it gets more point, if we have more points, right? So if you think about if x equal to 3, then you should get bigger, right? 2 to the 3 is 8. 2 times 2 times 2, right? They get even higher. So continue to rise up. And then same thing with the other side, right? -3. If x is -3, then it will give you a 1/8. Even smaller. Okay, so but then it will never, so just like a rational function, there's a 1/. So once again, there's no 0. It can never become 0. The denominator just gets bigger and bigger. It will be something like this. Okay, so for this one, it also gets an empty space. And Eric, what does this green line call?
An asymptote.
Yes, okay, so we only these two graphs, the 5th one and the 6th one, they get asymptotes, okay? But but for exponential, you only get 1. So asymptote line. Okay. So these two are very special. It doesn't have the vertical one, okay, for this one. Okay, if you finish the graph for the all 6 of them, please raise your hand. You just need to remember the X values, okay, for each of the tables. And the only one that's different is the radical one. Okay, Eric, are you done the graph? Yeah, okay. So as I mentioned at the beginning, right, these are the 6 basic cars, right, or truck, or like airplane, right, the basic functions. So they don't have any other adding to it, right? They don't have any armor, right, or any decoration, any transformation. Okay, so we're going to make them look different. Okay, but you need to keep in mind, right, when you see a question, you need to recognize, is it number 1, 2, 3, 4, 5, or 6? Which one does it belong to? So once you decided, okay, it belongs to, let's say, the cubic, then you cannot make the cube disappear, okay? You got to keep it in the same family, okay? So let's start with the first type, 3 types of transformation, okay? First type is reflection. So the basic function we are using for this one is the radical function, right? You can see it has a radical. Okay, so radical. So do you remember the points yet? Right, this is the special one. Philip, what are the points that we should use?
0, 1, 4, and 9.
Yes, okay. So this is the one, the only one that doesn't have -2, -1, 0, 1, 2, right? And then right away, because I know the X value, I just plug it in quickly and then make the graph. Okay, so 0, 0, 1, 1, 4, 2, 9, 3. Okay, I'll give you some time to write this down again. Okay, raise your hand if you're done. Okay, Evan and Jenny, you finished? Yep, okay. So for reflection, there are 3 ways to reflect. Okay, reflection means you want to, it's like you look at the mirror. So the image is flipped, okay? But you could flip different ways. If you look at the mirror, left and right side, it's different, right? But if you look at, for example, if you look down at the lake, right? Then it's up and down, it's different. Okay, so you can flip 2 ways. The first way, if you compare the equation now, okay, the 2 functions. This one, okay, compare with the basic. What's the difference? What do we have extra? Justin? How are these 2 look different?
The basic function one doesn't have a x square root.
The basic is square root of x, right?
Yeah.
Okay, what about the one over here? How is it different?
This has a negative.
Yes, okay. And it's the negative inside or outside the square root?
Outside.
Outside, okay? So please remember that, all right? So if there's a negative outside the square root, we want to see what it will do to the graph. So we're gonna use the same point. Okay, same x value, and then we plug it in, okay? And then let's find the y values. So for example, the first one, I plug in 0. I'll write it on the side here. Square root of 0, but then there's a negative at the front, right? But 0 times negative is still 0, so end up as 0. Okay, so our first point is still 0, 0. Okay, what will be the second point? Claire?
1.
1. Why is it 1?
Because 1. Oh wait. Because it just is.
Oh, because it is.
Oh, is
Okay.
it negative 1?
Huh?
Negative 1?
Okay, if we plug it in, right, the function has a negative in front, right?
Oh yeah,
So
negative.
the square root of 1 and then times it by negative. So it should be what?
Negative 1.
Negative 1, okay? So that's how it's different. Before, right, there's no negative. So if you plug in 1, square root of 1 is still 1, okay? It doesn't change. So we should have a negative 1. Okay, what about the next one? Sophie?
-2.
Yeah, it will be -2, okay? And next one, Caleb?
-3.
-3, very good, okay? So there we go. So you can see it affects the y value, right? The negative on the outside, it will change the value of the original, right? Compare the original y. Used to be positive, it becomes negative. 对，校长，那个 Lily 她有请假。Okay, so let's plot the point. 0, 0, okay, 0, 0. I'll let you finish the rest of the point and you can raise your hand, okay? Please raise your hand after you complete the graphs. -4, -2, 9, -3, right? So we have seen this as well, right? As we mentioned at the beginning, this is the lower half of the parabola, right? We have the upper half, right? When we learn about inverse, right? We have the upper half of the inverse and the lower half of the inverse together, right? If there's no restrictions, then you keep both sides, right? But if there's restriction, you only keep half of it. Okay, are you guys done the graph? Can you raise your hand? Okay, Caleb, Jenny, Marcus, are you done?
Yeah.
Okay. Does anyone have questions about how we get the points? Okay, are you done, Marcus?
Yeah.
Yeah, yes or no?
Yeah. Yes.
Yeah, okay. So raise your hand, okay? It's easier that way. Because I thought you said not yet. Okay. Okay, so this negative, okay? Now let's talk about how we can figure this out more quickly, right? We got this reflected, right? If you compare with the original, used to be up there, right? Going up and higher, it becomes lower and lower. So think about you are standing on the side of the lake, right? Here's the lake, right? And then you're standing here. Then your reflection will be something like this. Right? This part is the lake. Well, I messed up the color. Right? This part is the lake. Right? So that's a reflection. So you flip over to the bottom. Okay? So this way, if there's a reflection like this, we'll say reflect over the x-axis. Okay, so please fill that in, right? Because the reflection line is the horizontal line, right? The x-axis is the middle between the original and the reflection image. Okay, so when you have a negative outside the square root or outside the function, outside the basic function, then it will produce this kind of transformation. So similar, you can apply the idea, same idea to other function, right? We have 6 basic ones. For example, if let's say we pick the absolute value, remember absolute value one. So if you get something like y equal to negative on the outside, right? So right away you will know, right? Based on what we had just now, you know the graph will go reflected over x-axis. Okay, so that will be, you can apply this to any of the 6 functions. Okay, so negative on the outside, that's what it will do. So that's now another thing I want to talk about is the points as well. Okay, because later on it will get more complicated. We need to use points because the negative is outside the function, right? So it's affecting the y values. Remember I circled at the beginning, right? It used to be 0, 1, 2, 3. Now the y value becomes 0, -1, -2, -3. So all the y needs to times it by -1. And the reason why that will happen is because this negative on the outside, I can move it to the left side. If I want to move the negative to the left side, what should we do? Think about this, right? If I want to move this negative to the left, what should we do? Anybody? Yeah, Daniel?
You can either times -1 or on both sides, or you can divide by -1 on both sides.
Very good. Okay, so if it's movable to the y side, then it will be affecting the y values. Okay, that's the key word. If it's movable, right? So it can move either way. Let's say we move it by dividing. Okay, there will be y over -1 equal to √x. So now because the negative is movable, right? Of course, you can multiply by -1, okay? Doesn't matter. As long as it's movable to the y side, then it will affect the y value. So all the basic y point, you need to times it by -1. Okay? That's how you can get a table quickly, not just a rough shape. Okay? So if negative is with the y, we have a reflection over the x-axis. Okay, so let's try it. Let's write that sentence down. Okay, negative, right? This is a negative with y, reflect over x-axis. Okay, because this sentence is very, very important. So I would like everybody to turn on your mic right now and then repeat together, okay? So let's try it. We have a lot of people, I don't know what it will sound like. Okay, everyone, please turn on your mic. And let's try if we can sync together. Yeah. Turn on your mic, please, everyone. Angela. And Marcus. Oh, a little bit echo, right? Marcus? Yeah, okay. So let's repeat together. Negative with y. Everyone?
Negative with y.
With y.
Okay, reflect over x-axis.
Reflect
over
Over
x-axis.
x-axis.
Okay, very good. Okay, let's try one more time. Okay, negative with y.
Negative
Negative
y.
With y.
Good. Reflect over x-axis.
reflect
Reflect
over
over x-axis.
X-axis.
Very good. Just like in class, right? You can hear everybody else. Okay. All right. You can turn your mic off now. All right. So probably too much echo, right? For some of you, if you are not using the earphone. So later on, okay, because repeating it, it helps you to remember it better. Okay. Negative with y, reflect over x-axis. You try to repeat a couple times, just like someone tell you your their phone number, and you try to remember. But you don't have a phone, you don't have a pen, right? Then the only way is to keep repeating until you find a pen and paper, right? So this is why this will help. So even after a year, I'll ask you, what does this negative do? Negative with y, what happens? Right away, you remember reflect over x-axis. Okay, so let's try the next one. The next one, the negative is not with the y anymore, right? This time the negative is with the x. Okay, let me erase this highlight. So we have the second one here. Right, we have a negative. This time the negative is inside. Oops. Okay, you guys have to wait for me for a minute. It got crushed. I guess we were too loud, huh? So it crashed. Okay. All right, can you guys all see the screen now? Okay. Yeah, so over here, we'll finish this one, okay, before we take the break. So reflect over something, right? So this time the negative is inside the function. Okay, inside. So based on the rule that we had before, okay, when we had negative with the y, the reflection is over x-axis. Okay, yes, Susan. Okay, so when the negative is with the x, what kind of reflection do you think we should have then? Jenny, what do you think?
Would it be over the y-axis?
Yeah, it should be, right? Because it's the opposite, okay? So let's see if the points will actually confirm that rule, okay? So if it's reflected over the y-axis, and remember, if negative with the y, it affects the y points. So this time, negative with the x, it should affect the x points. Okay, so let's use the green circle this time, right? Our basic is 0, 1, 4, 9. So now all the x should become negative, okay? Because you have negative with the x. Okay, so you have 0. So instead of using positive, we'll use negative. And let's see what happens, okay? Because if I sub in positive number, then I will get negative inside. And you cannot square root that, right? So you must put negative number into the x this time. Okay, so please complete the table. Okay, plug in 0, -1, -4, -9 into our functions. And once you complete the table, you can draw the graph. You can raise your hand if you've done both, okay? If you finish the table and the graph. Okay, so CZ, clear Z. Can you tell me the Y value that you got?
0, 1, 2, 3.
Yeah, okay. So this time you can see it because the negative is with the X, right? Negative is inside with the X. So your Y value did not change. Same as basic, but your X has to change. Okay, compare the basic points with our new points. Right, so let's follow the points. 0, 0, -1, 1, -4, 2, and -9, 3, right? Could be this one. Okay, so this time the reflection is different, right? It's not looking down at the lake, it's like looking at the mirror. Okay, can you raise your hand if you finish the graph? And then you can think of it like, here's the mirror, right? You're standing here. And then you're raising your hand. Then your reflection will look like this. Okay, you're looking at the mirror, so your reflection should be like that. So this is reflect sideways, right? right side become left side become right side. So this is reflect, or some people they call it reflect horizontally, right? Flipping to the left, flipping to the right. Okay, Jenny and Jocelyn, are you done the graph for B? Okay, so we have, because the negative is inside with the X, so there's nothing you can move, right? So you just keep it there. You can write it as negative X, or you can write it as X over -1. It's the same thing, okay? So it doesn't matter as long as it's with the X. So when that happens, right, negative is with the X. So it changes the X point. So our rule for this one will be negative with X reflect over what, Chris? Reflect over what?
Y-axis?
Yes, okay, y-axis. Okay, pretty easy rule to remember, right? It's the opposite. Negative with X, reflect over y-axis. Okay, negative with Y, reflect over x-axis. Okay, so the second one of reflection is y-axis. Okay, does anyone have questions for part B? Okay, so far we covered two kinds of reflection, right? The one looking down at the lake, that's the reflect over x-axis, negative with y. Second one is looking at the mirror, negative with x, reflect over y-axis. Okay. How about let's just finish the last one, okay, before 11, and then we'll take a break at 11. So the third kind of reflection is something we learned last class when we learned about inverse. You remember we talked about reflection in the inverse? Does anyone remember? What kind of reflection do we have when we had inverse? Oh, we have one question here, right? Let's say, remember you guys asked this question number 16. Red one is the original, green one is the inverse, right? Where is the reflection line? If I want to draw a reflection line, where would you draw it? Okay, so yeah, okay, Claire, yeah, where would you draw the reflection line?
I don't know how to say it, but diagonally, like,
Are you able to show on the screen?
I could try. Wait.
Yeah.
Is it like, oh yeah, like here? Oh,
Yeah, very good, very good. Okay, so diagonally, yes, okay. So for any inverse graph, if it's on the upper left, it will flip over to the lower right. Okay, so if it's on the upper right, it will flip over to the, well, upper right. No, it won't. It will still do the same thing. It will flip over. So for example, it's like, if it's something like this, if it's there, it will flip over to here. Okay, so you have to turn your head a little bit sideways, right? And then think about you're folding it, right? You're folding this line, right? Folding the paper in half. Then the lower right will overlap the upper left, okay? Will be on top of each other when you fold it. So that's what inverse, okay? Our third kinds of reflection, okay? This is a reflection. Instead of horizontal, instead of vertical, we have a diagonal, reflection. Okay, so let's go back to that. Oops. Okay, so our questions here, third one. So this one reflect over diagonal, right? But we don't write diagonal line, we need an equation. That line is called the y equals x. Okay, you can put a bracket and then write down diagonal. So the graph, okay, so the equation first, right? So you can see y equal to square root x. Now it becomes x equal to square root of y. You just switch x and y, right? For inverse, x and y switch. And how do we get a table then? Evan, how do we get the table for the inverse?
Don't you just flip x and y too?
Yeah, so can you tell me the table then?
0, 1, 2, 3.
Yeah, 0, 1, 2, 3, and then the y.
And then 0, -1, -4, -9.
We are comparing, we are flipping the basic one.
Oh, okay. Never mind. 1, 4, 9.
Yes. Okay, so we always compare with the basics. That's why it's called basic. So all the transformation is starts with the basic. So you can either add a negative to the basic, or you switch x and y to the basic. Okay, then you get a new graph. So now please follow the points and do the graph. Okay, let me know when you finish. Just raise your hand. So this is the upper half, right? So if it's the upper half, inverse, it should give you which half? Think about this one, right? And you can compare with your answers if you got it right. Upper half, inverse is which half? We have 0, 0, 1, 1, 2, 4, 2, 4, 3, 9. Okay, please raise your hand if you finish the graph. Okay, so this gives you the right side, right? Right half. This is open to the original basic is open to the right. Inverse become open to the up, right? Opening up. Okay, so how do we remember this one, right? The rule for this reflection. We can say inverse reflect over y equals x. Okay, when you see the word inverse, you right away think about x and y got switched. So you need to be able to recognize the equation as inverse. Okay, and remember you can apply this to any of the 6 functions. Okay, so Jenny, are you done with this graph? Yeah, okay. So before we take a break, right? So let's think about, for example, if I want to do the same thing to, let's say, number 5, right? I want to graph the inverse for this one. Then the equation, I got to switch x and y. So x, it will be x. For example, if they tell you, okay, it's x equal to 1 over y. Then you need to flip this graph diagonally. Here's a diagonal line. Okay, everybody try it. If I want to flip this diagonally, just find an empty space. What will the new graph look like? Okay, Eric, what do you think? What's the new graph look like?
Will it be the same?
Yes. Okay. So this is the only one when you inverse, it actually just look the same. Okay, because the diagonal line just went through right in the middle. Okay. But for other ones, right, probably won't, right? So for example, like number 3, if they give you a question, okay, they say, please graph, well, it's inverse, right? So you got to do switch X and Y. Please graph this one. And then you recognize, okay, this is absolute value, right? So let's think about basic. Okay, the basic look like open up. And this is inverse. So open up, if I inverse, it should be opening which way? Marcus, if it's open up, when inverse, which way would it open?
Down.
No,
I don't know.
it should be opening sideways,
Oh,
right? Original up and down, open up, open down. Inverse will be opening left or right side. So if it's open up, Marcus, it's still you, okay? So open up, when you inverse, which way would it open?
sideways.
Yeah, sideways by which side? You have left side, right side, which side?
I'm not sure.
You think about positive, okay, or negative. Open up, is that going to the positive or the negative side?
Positive.
Yeah, going up is positive, right? So now if you're going sideways, left side, right side, which side is also positive?
Right.
Right side. So inverse will be opening to the right. Got it?
Yeah.
Okay, so if original is open down, which way would it open when it's inverse? Marcus?
Left.
Yeah, okay. So down and left, they're together. Up and right is together. Okay, so for this one, right? If it's inverse, it will look like that. So these rules, okay, you have to put them all together. And you can apply it, okay, any of the 6 functions, okay? So during the break, okay, spend a minute or 2, repeat these 3 rules, okay? Negative with y, reflect over x. Negative with x, reflect over y. Inverse, reflect over y equal x. Okay, let's have a break. And then we'll come back at 11:15, okay? And if any one of you still need to complete the homework, yeah, I'm still missing 2 homework. Okay, please do that during the break.